All right, last lesson of chapter 24, just mostly dealing with graphs and how those relate to the calculus that we've been doing this chapter. So I'm kind of hacking up the notes here a little bit. We're going to show three main examples that you just need to be familiar with. So for the first one, it says find the values of x for which the function is increasing. So we've talked about that before. This basically refers to the area of the graph where the slopes are positive. So for number one, if we were to, let me just start with identifying the derivative of this function. So 1 plus 4x minus x squared. So kind of separate this off here for example number one. So the original function we have is the 1 plus 4x minus x squared. So the derivative of that, using our power rule, would just be 4 minus 2x. So there's our derivative function. So if we are looking for the areas for where the graph is increasing, that means we can do what we've done in the past, and I showed how we could use what we call a sine graph. And this is something you do need to be familiar with. So the sine graph is how we show where the graph is increasing versus where it's decreasing. What we looked for in the past was the numbers that go on the number line are the areas of the graph where the derivative is 0. So there is no sign change or anything for those points. And so if I set the derivative equal to 0, because remember it's those 0 slope points that separate out the pluses from the minuses. So we always have these in between any sign change. So anyway, if I subtract the 4 over and divide by -2, then I can see that where x is 2, I have a 0 slope. So that's the only one, so that's the only number I need on my sine graph here on the number line. And what we have seen in this in the past is we just need to test some numbers. If I test any number on this side of 2 into the derivative, it's going to tell me what kind of slopes are on that side of the graph. And if I test any number bigger than 2, it'll tell me the same thing on the other side. So if I take a number like 0 and sub it into the derivative, well, 4 minus 0 is positive 4, so I know the slopes in this area are positive. If I plug in a number bigger than 2, like let's just pick 3, so if I plug that in right here, then 4 minus 6 is -2, which means slopes are negative in that area of the graph. So my graph is increasing where x is less than 2. And so that's one simple way of answering that question. So that's where the graph is increasing. One thing to look at on that is, remember this is a parabola right here. It's a decreasing parabola. So if you were to kind of look at that in a graph, right, you would have this look right here, right, which means you can see here's the vertex, and that's where the slope is 0, is at the vertex, is at the max. So to the left of the vertex, it's increasing, and to the right of the vertex, it's decreasing. So positive slopes and negative slopes. So if we just found the vertex of the graph, that would also help us identify this point. And so here's kind of the way we've done that in the past. But if I go to that first equation up there and graph it, so 1 plus 4x minus x squared. So if we graph that, there's our negative parabola. In this case, the vertex is a maximum point. So if I hit second calc and choose maximum, so they're going to ask me those boundary questions. So here's my vertex. So for the left boundary, just go left a couple times and hit enter. For the right boundary, just be to the right of the vertex and hit enter. Hit enter again, and there you go. We can see at the point, that's essentially 2. So 2, 5 is the vertex. And so just based on that graph, I could see the answer to the question that they were asking, and that didn't even really take any calculus to figure that out. I just interpreted that from the graph. So something you could take advantage of, but again, I do want you to know how to make a sine graph like this, because you'll be asked to do that. So moving on. if you jump to number 3 says find the minimum value of that function. So here's the function we're working with, x to the 4th minus 4x to the 3rd. So there's our function that we're working with on this one, and it says find the minimum value. So the minimum value, remember this would be a maximum value. A minimum value would be at a low point in the graph. So how do we do that? Couple options, couple ways we have in doing that, and I'll kind of show you both. So kind of like what I did on this one, I'll show you the calculus version, and there's also a calculator graphing version for how to do this. So if I want the minimum point, one way to do that is to work with the derivative. So here's the calculus way of doing this. And I would start it like the way I started this sine graph. Although it's the only thing that's different now is this is the guy I'm looking for. I want to know where is the slope 0, because remember what we've talked about already. Anywhere you have a maximum or a minimum, that's where you have 0 slopes, or horizontal tangent lines are at a max or a min. So as soon as they say find the maximum or the minimum, automatically that means my derivative equals 0, and I'm solving for x. So if we factor out a 4x squared on that, leaving us with this. If I set my factors equal to 0, then x equals 0 and positive 3. All right, those are my 0 slopes, but I don't yet know where the maximum is or where the minimum is. I don't know which one of those is which. So one way to test that is the way we did up above with the sine graph. So I know I have 0 slopes at these 2 locations. I need to know what's going on with the signs in those areas. So if I pick the number smaller than 0 and plug it into the derivative, that will tell me the slopes in that area of the graph. And so if you pick any number smaller than 0 and plug it into the derivative, in this case, you're going to get all negative answers. So negative slopes in that area. Pick any number between 0 and 3, plug it into the derivative, and you're going to find that the slopes are negative there also. But if you pick any number bigger than 3 and plug it into your derivative, you're going to see in that area you get all positive slopes. So what does that mean? That means if this is my graph, and this will be a rough sketch. So looking at this, and I'll get a better graph on the calculator in a second, but what that means is somewhere in that graph it was negative. It flattens out to get a 0 slope, then goes negative again, and then turns positive. It does something like this. So I know the graph is doing something like that because it went negative, negative, positive. So where would you have your minimum value? Right? A minimum value occurs when you go from negative to positive. Right? A maximum value occurs when you go from positive to negative. And again, the minimum is from negative to positive. So I know my minimum value was occurring at this guy, so I know the x coordinate is 3. And if I plug that into the original function right here, then I get the y coordinate that would go with them. And it does come out to be negative 27 if you do that. So this is the point where I have the minimum value. So yes, you can do this on a calculator as well, even without the calculus. The calculus you need to know in case you're asked to show it. So there's going to be cases where you're simply asked to show with the use of derivatives how this works. So I want you to know both ways of doing this for your own good. So anyway, if I go ahead and graph this guy, so x to the 4th minus 4x to the 3rd. And let me see if my window's okay here. There we go. Okay, so I got to go a little lower, so let me lower the y minimum. Let's just say negative 30. There we go. So here's what you're seeing. We went from negative to 0, 0 slope, to negative, to 0, to positive. So I can see here's the minimum. Obviously, that is not a minimum point because you went from negative to negative instead of negative to positive. So you got to go from negative to positive in order to have a minimum. So anyway, if I go under Calc, choose minimum, answer those boundary questions. So there's the minimum. So left a couple times, enter. Right a couple times, enter, enter. And there you go. At the point 3, -27, you have your minimum. So that was all done purely on a graph, even without the calculus. But what I want you to really see on this is how do we link what we've already done in the past to the calculus that's now involved. So anyway, one more problem. We're going to do 5 and 6 as one problem here. So it says to find and classify all the stationary points. So they're giving us this function, so that's the one that we're going to use here. So we're doing 5 and 6, but we're going to do it on this function. So we're looking for all the stationary points. We need a sketch of the graph based on those points, and we're going to mark stationary points. So what's a stationary point? A stationary point is any point where your slope is 0. So we've seen now basically there's 3 ways that can occur. That can occur at a minimum. All right, this would be a stationary point, is anytime you have a minimum, because there the slope is 0. It would occur at a maximum, right? Because even at this point at a maximum, your slope is 0. So those are 2 stationary points, but there actually is a third, and it was this guy. This one right here is not a max or a min, but it does have a 0 slope. The sign did not change on either side of it, so it's not a max or a min, so they give it a special name, and this is called a point of inflection. So let me write that off to the side. That is a point of inflection. So a point of inflection, it does have a 0 slope, but again, it's neither a maximum nor a minimum. So those are the 3 types of stationary points you can have. So working with the function that we had up there for number 5, so this will be for 5 and 6, and this is where we'll finish off the notes. So x to the third minus 3x squared. Minus 9x plus 1. So that's the function that we're working with. Well, how do you find stationary points? Well, as I just said a second ago, a stationary point has a 0 slope. So if you take your derivative, so in this case using the power rule, we should see the 3x squared minus 6x minus 9. And if you take your derivative and set it equal to 0, that's going to help you find your stationary points. In this case, it looks like a nice shortcut would be to divide the entire equation by 3, just to give us some smaller numbers to work with. That's a little easier to work with than to factor. So if we were to factor that, should be looking at, looks like x minus 3 and x plus 1, which means the solutions are positive 3 and negative 1. All right, so stationary points, those are the x coordinates. We got to plug those in to get some y coordinates. So if you were to plug in 3 into the original function, you're going to get negative 26 for that y coordinate. And if you plug negative 1 into the original function, you're going to come out with 6 as that y coordinate. So one thing we're going to need to do with those is to classify them. How do I know if those are a minimum or a maximum? Well, I've showed you 2 ways. One way is with the sine graph. So I know I have 0 slopes in these areas. So if I were to test the numbers around them, I could see what kind of slopes they have. If you plug in any number smaller than negative 1 into the derivative, you would see that all the slopes in that area are positive. And if you plug in any number in this area, like 0, into your derivative, you're going to find all those guys are negative. And any number greater than 3 in the derivative is going to give you a positive slope. So how do we interpret that? Well, around -1, if I am going from positive to negative, right, that means I'm going from positive to negative. It's going to look like that. That means right there I have a maximum. So I know this guy is a maximum point. Around the 3, if I am going from negative to positive, right, that would occur at a minimum point. So that's how we classify those. You could do that on a calculator. If you were to graph this function, you could clearly see on the graph itself that this point is a minimum, kind of like this. So you'd see this is a minimum, and you would see that this is a maximum. So you can kind of use your calculator for some guidance on that as well. But the sine graph is another way to go. You're going to be asked to show a sine graph, so that's why I keep showing how to do those. But anyway, if I wanted to now create the graph, just using what I know, I'm going to plot my stationary points. So the 3, -26, I'm just going to have to estimate that. That's pretty low, so let's just call that 3. Let's call that 3, -26 down there. And if I graph the point -1, 6, -1, 6 would be about here. So I know those are stationary points, and I know to the left of -1 it was increasing. So I was increasing. I then hit my 0 slope. Now I am decreasing all the way to this point. So now I am decreasing. I then have another 0 slope, and then to the far right, you can see right here, again, now I am increasing again. And there's my graph. So I know the graph is going to look like that, and I did all that without the calculator. So that's one way we can use this idea of stationary points to help us make a graph, even without our graphing calculator. But of course, I could have thrown this into my graphing calculator and gotten the graph that way too. But one thing you're going to have to do on your test is this area right here. You're going to have to find and classify stationary points. You're going to have to show a sine graph to support that. And you're also going to have to show a graph. So these are all things that are going to be asked of you, which is why I'm showing those. But that is it for Chapter 24.